You know that feeling when you walk into a perfectly cool room on a blazing hot day and just wonder, how? How does this even work? Well, today we're going to pull back the curtain on that whole complex world of HVAC. We're actually using a university syllabus as our guide to break down the science of cool into pieces that just make sense. So let's dive in. All right, here's our game plan. We're going to start with the why. Our constant quest for comfort. Then we'll get into the real magic of the refrigeration cycle. After that, we'll look at the anatomy of an AC system, check out the different types for different spaces, and finally, we'll touch on how the pros figure out just how much cooling power you actually need. So, first things first, let's talk about the whole reason these systems even exist. It all comes down to a really simple, totally human desire to just be comfortable where we live and work. It's not just a nice to have, it's actually a science. Okay, so it's an acronym we hear thrown around all the time, right? Especially when it gets hot. But what does it actually stand for? Let's break it down real quick. HVAC stands for heating, ventilation, and air conditioning. Pretty straightforward, but its job is way bigger than just making a room hotter or colder. As our syllabus points out, it's also all about maintaining good indoor air quality, or IAQ. And that means managing humidity, filtering the air, making sure it's fresh, all the little things that our bodies notice and tell us, this feels comfortable. Now for the fun part, the how. How does an AC unit actually make the air cold? I know it feels like some kind of magic, but it's just pure physics, and it all boils down to one really brilliant idea. And here it is. This is the big secret. Air conditioners don't create cold air. They move heat. Just think of your AC unit as a little heat taxi. Its only job is to pick up heat from inside your room and drop it off outside. This whole process of moving heat around is what we call the refrigeration cycle. And that cycle happens in 4 key steps. First, there's a compressor that squeezes a special liquid, a refrigerant, which makes it super hot. Second, that hot gas zips through some coils outside, the condenser, and releases all its heat. Third, the refrigerant then expands, which makes it get really, really cooled. And finally, that ice-cold refrigerant flows through another set of coils inside your house, the evaporator, and sucks up all the heat from your indoor air. And that's our heat taxi in action, a nonstop loop of grabbing heat from inside and kicking it outside. Okay, so we get the process now, but what about the actual hardware? What are the key pieces of equipment that make this whole refrigeration cycle and air movement even possible? Well, to see what those parts are, we can go straight to the source. The university syllabus itself lays out the complete anatomy of an HVAC system for us, from the giant units you see on roofs all the way down to the little vents in your ceiling. Let's just look at a few of the big players here. You've got the air handling unit, or AHU. Think of it as the lungs of the system. It's got the fan and the coils that treat the air. Then the building ducting. That's like the airways, the network that delivers the cool air everywhere. And finally, you have diffusers and grills. Those are the vents you see that make sure the air spreads out nice and evenly. See? It's a whole team of parts working together. Obviously, not all buildings are the same, so it makes sense that not all AC systems are the same either. So let's look at how all those parts get packaged together into different kinds of systems for different jobs. You can really put systems into 2 big buckets. First, you have single-zone systems. They're designed to cool just one specific area, like that classic window unit you'd put in a bedroom. Then you've got the multi-zone systems. These are the heavy lifters designed to cool entire buildings, like the central air system that serves a whole house. And this table here breaks it down really nicely. At the simple end, you have your basic window AC, perfect for one room. A split system is a step up, a bit quieter, good for a few rooms. But then, as you move to central air and these big package systems, the complexity shoots way up, because now you're trying to cool entire homes or massive commercial buildings. Basically, the bigger the space, the bigger and more complex the system. So you get the science, you know the different types of systems, but how on earth do you choose the right one? Well, the final piece of this puzzle is making sure you get the size just right. This is done through a process called a load calculation, and it's the super detailed analysis that looks at everything. The size of your windows, how much insulation you have, even how many people are usually in the room. The whole goal is to figure out the exact amount of heat that needs to be removed. It is the crucial first step for any installation, whether it's for a tiny apartment or a giant office building. And why does this matter so much? Well, think about it. If the unit is too big, it'll waste a ton of energy, and your electricity bill will be sky high. If it's too small, it's just gonna run and never be able to keep you cool on those really hot days. Getting that load calculation right is the absolute key to having what our syllabus calls an energy-efficient system. You know, in the end, this all comes back to a little quote from our source material. The goal is to give the learning in this subject a more practical orientation. And that's what this is all about. Understanding these basics isn't just for an exam, it's about making smart, efficient choices out in the real world. And that kind of leaves us with one last big thought. We've just gone through the fundamentals of how we keep ourselves cool today, but with our planet getting warmer and the demand for cooling going up, you have to wonder, how is this technology going to have to change and adapt? What's the future of comfort going to look like? That's a huge question for all of us to think about.